Namaskar. This is the fourth lecture of drying, and in this lecture we will study about spray dryer and fluidized bed dry. I, Dr. Satya Prakash Singh, Director of Babu Sundar Singh College of Pharmacy, will continue this lecture. Now, the first dryer of today's session is spray dryer. Okay. So, in this case we will also study the what is the principle behind this spray dryer. In case of spray dryer, what is happening, liquid is sprayed into small droplets by the use of this atomizer. So, with the help of atomizer, liquid is sprayed into the drying chamber and each droplet dries to a solid particle. So, this is the principle behind this spray dryer. What happens, the feed which is used in spray dryer, it may be either solution, suspension or paste. So, these three type of materials can be taken into or can be dried with the help of this spray dryers. Construction. So, it consists of a large cylindrical drying chamber with a short conical bottom. So, as you see the diagram of this spray dryer, this is a cylindrical drying chamber. At this bottom of this chamber is, you will see it is a conical chamber or short conical bottom. This dryer is made up of stainless steel. Diameter of this dryer is 2.5 to 9 meters and height is around 25 meters or more than that. So, the diameter is 2.5 to 9 meters and the height of the dryer is around 25 meters. Further, if you will move further, there is an inlet for hot air. Okay. You see in the diagram, this is the tangential air inlet, and here a point is there for hot air. So, this hot air is introduced into this chamber and from here it is entering into the drying chamber in this fashion. Okay. So, this inlet is called as tangential air inlet. So, this hot air inlet is placed on the roof of the chamber and another inlet is there. This inlet is for liquid feed or the substance which is to be dried, that is introduced from this liquid feed inlet. Spray dryer atomizer is about, so this is the atomizer of spray dryer, it is about 300 millimeter in diameter and the speed of rotation of this atomizer is 3000 to 5000 rpm. Bottom of the dryer is connected to cyclone separator. So, this portion is connected to cyclone separator. Now, working of spray dryer. This spray drying process, it involves 4 basic stages. First one is atomization of feed into the spray. So, when a feed is atomized into small droplets, its specific area increases, since as the particle size is decreased, the effective surface area of particle increases due to decrease in size. So, due to this, the drying takes place at a very fast rate. The instrument that produces small droplets is called as atomizer. So, this is the instrument which produces small droplets, that is called as atomizers. Basing on the atomizers, our atomizers are classified on the mechanism involved in breaking the bulk of the liquid. It is of 3 types. First one is centrifugal atomizer, for example rotary atomizer. So, in this type the liquid is distributed centrally on a wheel disc or cup which is rotated at a very high speed. So, the liquid, in this case the liquid is extended as a thin film over the disc. After that the this liquid film disintegrates to produce fine droplets. So, this type of atomizer, that is centrifugal atomizers, these are used for slurries or pastes having thermolabile substances or abrasive materials or corrosive materials or very high viscous property materials. In those cases centrifugal atomizers are used. Pressure atomizer. Next atomizer is pressure atomizer. Example is centrifugal pressure nozzle. In this case the liquid is fed through a nozzle under pressure. This fed liquid is coming out from the nozzle as a thin film, and as soon as it is coming out, it disintegrates into a spray. The feed rotates inside the nozzle, so that a cone shaped spray pattern is obtained in this way. As the feed is rotating inside the nozzle, cone shaped pattern is obtained. So, this type of atomizer is used to obtain coarse particles. Third type is pneumatic atomizer. Pneumatic atomizer, in this case the example is two fluid nozzle atomizer. So, it involves the impact of liquid with high velocity gas. This high velocity gas or air is involved in this case, and high velocity gas creates a high frictional force over the surface of liquid, where over the surface of liquid this creates a high velocity, high frictional force. This leads to disintegration of liquid into droplets. Use of this pneumatic atomizer are feed of high viscosity feed produce coarse. If you are using pneumatic atomizer, in this case high viscous substances are used, then the feed produces coarse particles. If the viscosity of feed is less, then it produces fine particles with more uniform product. The second stage, as it has been discussed earlier, that spray drying process involves 4 basic stages. First one was atomization. Now, the second stage is spray air contact. That means, after spraying the material, the contact of air with spray with the particles. So, spray and hot air can flow in 2 ways: co-current flow or counter current flow. What are the ways? Co-current flow and counter current flow. These are the 2 processes in which both spray and hot air both are moving inside the direction. In co-current flow, the spray and the hot air is passed in same direction, both are moving in same direction. So, what happens in this case? Fresh droplets comes in contact with hottest air. So, solvent evaporates and the droplet as the solvent evaporates, the droplet temperature falls to wet bulb temperature. So, with this process or in this process, in this case heat sensitive materials can be dried, because the time of contact is less. Second type was counter current flow. That means, the flow of spray and hot air both are moving in opposite directions. In what happens, the dried product comes in contact with the hottest air. Hence, this type of flow is suitable for heat stable or thermostable materials. How? Because since air and spray both are moving in opposite direction. So, suppose this is the position of hot air or fresh air, here the dried products are coming. So, this dry products comes in contact with the hottest air. That is why this is suitable for thermostable materials. Third step in this case is droplet drying. The heat is transferred to droplets by convection from air. So, the mechanism is convection. So, as heat is transferred to droplets by convection from air, moisture from the interior migrates to the surface and evaporation takes place from the surface. So, the surface becomes dried quickly. So, surface becomes dried quickly and the moisture in the interior produces vapor that expands the droplet. So, in this way the final product depends on the nature of the surface layer. The last stage of this spray drying process is separation and recovery of dried products. So, majority of dried products falls to the base of the chamber where primary separation takes place. The particles which are entrained in the air is recovered by separation equipments like cyclone separator or bag filters or electrostatic precipitators or wet scrubbers. By using any of these separating equipments, particles can be separated. So, in short, what is going on? This is the point for hot air inlet. Through this, feed is introduced and with the help of this atomizer, feed is sprayed into this chamber, drying chamber in a centrifugal way in this circulating manner. From there, the hot air is moving out and the dried products are collected from the bottom of the container. Advantages: it is a continuous process. So, drying completes within 3 to 300 seconds, labor cost is low, uniform sized products can be obtained, fine droplet provides large surface area for heat and mass transfer. So, products shows excellent solubility. Disadvantages: it is a very bulky and expensive process, huge equipments is required. So, it is not easy to operate, thermal efficiency is low as heat large amount of heat is lost in the form of discharge gases. Uses: the product is a better form than obtained from any other dryer, quantity to be dried is large, product is thermolabile, hygroscopic or it can undergo chemical decomposition. So, these type of products can be prepared by using spray dried lactose like that. Next dryer is fluidized bed dryer. So, principle, let us consider a situation where a bed of granule is placed over a perforated bottom container. So, let us suppose this is a container, on this at the base there are holes or perforations are there. So, over this a bed of granules are placed on this container, and hot air is flowed from the bottom of this chamber or flown from the bottom through this bed. The pressure drop across the bed and the velocity are measured. If air velocity is gradually increased and delta p is plotted against v, then this type of curve is obtained. In this curve, point A, it indicates when the velocity is very low, flow takes place between the particles without causing any disturbance. As we are moving in this direction, velocity is increased. As the velocity is increased to a certain value, the fractional drag on the particle becomes equal to the force of gravity of the particle. You see, as the velocity is increased, p value is also increasing in this direction to a certain extent. At point C, at this point, rearrangement of particle occurs which offers least resistance. Further moving further, or as velocity is further increased, what happens? There is a slight decline up to this point D. So, the particles are suspended in the air and it can move freely. So, as you see in the graph, delta p decreases slightly due to greater porosity. After that, with further increase in velocity, it causes the particles to separate and move freely, and the bed is fully fluidized. In this condition, the bed is fluidized. Any additional increase in velocity, it separates the particles further. So, the bed expands without appreciable change in delta p until the value E up to this point. So, in DE region, the air flow through the bed is in the form of bubbles. So, this is called as boiling bed. Above point E in solid particles, at above point E, the solid particles enters above this point, the solid particles enters into the gaseous phase and the particles float in the gas. Now, construction of this fluidized bed dryer. You see this here, air inlet is there, besides that air outlet is there, a fan is attached for circulating the air. Here the heaters are present which heats the air, and from this, in this way, from here the heated air enters at the bottom of this chamber, fluidized bed dryer. Okay. Above this, you see the filter bags are there too. So, there are two types of, this is the basic construction of fluidized bed dryer. There are two types, vertical fluidized bed dryer and horizontal fluidized bed dryer. This vertical one is used for batch process, fluidized bed dryer, horizontal one is used for continuous process. As the dryer consists of certain parts, first one is air handler. This section is called as air handler. The source of dry and hot air, air handler, it is the source of dry and hot air attached by means of heating and dehumidifying air if necessary. Second part is plenum. It consists of a screen, that means this one, this area. It consists of a screen or plate to distribute the incoming air as it enters into the dryer. So, this portion is called as plenum. Then product container, this this is the product container, this holds the product that is to be dried. Next is expansion chamber. So, this portion is called as expansion chamber. The chamber is situated above the product container and holds the suspended material. And the next part is filter. The upper part of expansion chamber has bag filters. So, these are bag filters. So, this bag filter, it prevents fines from escaping into the atmosphere or collecting on the blades that pulls the air. So, as the air is going out through this outlet or the fan is pulling the air, the function of this bag filter is to filter the fines or to prevent the fines from escaping. Advantages of fluid bed dryer: it requires less time for complete drying, that is 20 to 40 minutes time is required for complete drying of a product compared to 24 hour of tray dryer. Different sizes with different capacities of dryers are available, that is from 5 to 200 kg per hour efficiency size are available. Handling is simple and labor cost is also low. Thermal efficiency is 2 to 6 times more as compared to tray dryer. Mixing efficiency is also high as compared to other dryers. It facilitates the drying of thermolabile substances can be dried by using fluidized bed dryer as the contact time is less or short. Disadvantages of fluidized bed dryer: many organic powders develops electrostatic charges during drying. So, to avoid this, efficient earthing of dryer is essential. So, if earthing is not done, then there are chances that the operating persons can get electrical shock. Turbulence of fluidized state of granules causes attrition of particles, which results in the production of more fines. Fine particles are entrained and can be collected by bag filters. So, these are certain disadvantages of fluidized bed dryer. It is popularly used for drying of granules which are used in the production of tablets. This can be used for 3 operations like mixing, granulation and drying. All these 3 purposes can be done with this fluidized bed dryer. It can be also used for coating of granules also. So, these are some applications of fluidized bed dryer. Thank you.